Okay, so let's continue on with Appendix A. And here is some code where I have several methods. And what I'd like to do is I'd like to search for a given object, the target, in an array. So I want an integer target inside an array of integer objects. And here's the code. I set the index to 0. I have this while loop that uses a compound condition. By using this, and I'm going to talk a little bit about programming style. This is sort of weird. You don't see this often, but this avoids having to have a break statement. A lot of people have a break statement or they'll have two return statements. They'll do something like this, and this is just, I think this is just awful, but they'll do something like this instead. They'll say, while true, if array subindex dot equals target, return index plus plus if index greater than array dot length break. That has to be greater than or equal. This is really ugly code. Please don't write something like this. Whenever I see while true with break, that tells me, okay, this person did not even stop to think about what's the correct way of getting out of this code. So please don't use while true with break. You can, break is okay, but I'm not a big fan of it. Let's put it that way. Yeah. Yeah, it is. It's lazy thinking, to be quite honest. Another way you could use break is you could say while the index is less than array dot length. Actually, this wouldn't be a break, but if array subindex dot equals target, then return index, and then you do index plus plus, and then after that you'd return -1. There's an implicit break because return gets you out of everything. And this is slightly better than while true with break. One other thing, by the way, the if and while and for are not methods. According to our style guidelines, they're always followed by a space. And that's just, you'll see books where they have different guidelines. But for this course, please always put a space after if, for, and while, because they're not methods, they're statement types. Coming back to here, so as long as the index is in bounds and I still haven't found what I'm looking for, I'm going to add one to the index. Then here I have this weird thing. How many of y'all are familiar with the question mark colon notation? Okay, this is one of my favorite operators. Mod is my favorite operator. This is my second favorite. It's called the ternary operator. And here's how it works. You can say variable becomes expression, question mark, A, otherwise B. And that is the same as saying, if the expression is true, variable becomes A, otherwise variable becomes B. So it's a really nice shorthand for that. So let's go and take a look at this, what I have here. Copy that. Paste that in here. So that's the equivalent of saying if the index is not equal to the array length, then index, actually I have to put a return here. But anyway, that's what's called the ternary operator. Most of them are binary operators. You have two operands. This one has three operands. It has the expression, the first value, and the second value. And sometimes it's just really nice and easy to write things like this way. Okay, so there's my search method for integers. Now, what if I want an array of strings and I want to search that for a target? Okay, it's exactly the same code, but the only thing that's different here is that I'm using a string instead of an integer as my object. And remember our circle that we did on Monday? Well, I added an equals method so I could compare to make sure that the x, y, and radius are within are close enough to each other. And so if I want to search for a given target circle inside an array of circles, again, the code is exactly the same. The only thing that's different is this data type. Is everybody okay with this idea? And then here's my test program. I'll set up an array of integers. I'll look for where 9 is and tell you where it was found. I have an array of words. They're strings. Here's my target. I want to see where that was found. And here I have an array of circle objects, which I can initialize. And then this is the disk that I want to find. And I'll do hello, I can just call this disk to find. This happens to me a lot. I'll declare a variable and then I'll never use it for some reason. There we go. And in fact, if we compile this and we run it, and it works. However, this is not terribly satisfying. And the reason that this isn't satisfying is because what happens if there's some other, like rectangles? Now I've got to add another method for rectangles. And if I have some other object like cities and I want to compare them find one of those in the list, then I've got to add yet another method. Gee, wouldn't it be nice if I could say, look, I want this code here, but we'll fill in the blank later on for what we want the data type to be. And that's what generics do for us. So let's save this under a different name, searcher generic.java. And we're going to call this a searcher generic. And inside of angle brackets, we're going to say, we're going to give you a data type when we create one of these, and then you can use that data type, whichever one we give you. Then, and I usually, it's almost always a capital letter, and we use T for some unknown type. So essentially, it's a lot like variables, except instead of putting values like 3 or 4 into a variable, we're putting a data type into this generic variable. Now I don't need any of these at all. Actually, I should call this searcher. That will make my life a lot easier. And this is more where I have to call it searcher generic. So now what I'm going to do is I'm going to have a searcher of integer, and that'll be a new searcher that searches for integers. Then I can call its search method, and its integer is going to fill in this blank here. So when I execute searcher.search, it'll use integer array, integer target. And then here, I can say, oh, actually, I've got to call it searcher here, don't I? I have to give it a variable name, otherwise that ain't going to work. Okay, and I can have a searcher of string called string search, and that'll be a new searcher. And by the way, you can leave off the data type on the right-hand side. Java will figure it out for you. And then I want to do a string search for that. And then here, I'm going to have a searcher that uses circles, and is going to be called, let's call it disk search, is a new And then I have disk search. And I think this should compile okay. And when we run it, oh, this is interesting. This says it wasn't found at index -1, which it should be found, and I'm not sure why that is happening. So I'm going to have to look at that in a couple of moments to see what's going on with that. Okay, because it should be right here. So there's a bug in my code for doing circle equality. And I will look at that later, but that idea, I don't want to do that right now because that distracts from the idea of this generic business. Yeah, but the whole idea is that now you can have a class where the data type isn't known right away, but when you create one, you tell it what kind of data type you'd like to use. It is also possible, by the way, to do this. I did this with a class. It's possible to do it with a single variable, a single method, excuse me. Let me see here where this is. And that's here. So I can say this method is a generic method that works just for that one method. And I can then make it all. Well, let me just grab this and paste it in here. Called there it is. Now, there are some other things that we would like to know about generics. This is the simplest version of generics that there is. One other thing, though, is that you need to specify limitations on the types that can be used for a parameter. Let's say I wanted something that would be a sorter class. Okay, you could only sort objects that have a compare to method. Okay, so if you don't have a compare to method between your two classes, if you have no way to compare them, you can't sort them into order, right? Is this okay so far? Okay, do you need me to repeat any of this? Do you need me to go over some of this again more slowly, by the way? Because I have a feeling that I barely understand what I'm talking about myself at this point. Yeah? Okay. Let's go over this example one more time here then. Okay. Before I go into the business about another version of generics. Yeah. Here was our problem that we had. We had a whole bunch of methods that were all exactly identical, except for the data type of their parameters. Everything else was exactly the same. You're okay with that idea, right? Gee, wouldn't it be nice if we could avoid having to duplicate this every damn time? That's the problem we're trying to solve. And here's how we solve it. We're going to say this class searcher is going to have a generic type T. Okay, so for any data type T that you give me, I'm going to write a search method that will take an array of that data type and a target of that data type, whatever it is, and then I will figure out whether it was in the array or not and where it was. So now I have exactly one method that will work on any data type at all that's an object. Does that clarify it a bit? Now, when I create one of these searcher objects, I have to say what kind of data type I'm going to be searching. Is it going to be an array of integers? Is it going to be an array of strings? Is it going to be an array of circles? And the only way we can do that is to put this in angle brackets, and this data type fills in this placeholder, and the generic placeholder. So that cleared it up a little bit. You know what? Let me just take a real quick look on this circle one. This is really bugging me. Is why yeah. I just wanted to let's just. This is really weird. The circle worked fine. It found it at index 2. But when I used the searcher generic, it didn't find it. So I'm going to have to look at what's going on there. Once I will fix that later on, okay? I have no idea why it's doing that. That's very strange. Okay. Now, this happens to work for things like strings and integers because every object has an equals method, turns out. Sometimes, though, you'll have objects that you're going to be using and you have to have limitations on them. For example, if I want to, in fact, let me see if I can find this here. Did I write this earlier? No, I did not. Okay, fine. In fact, let's take this one here. So the object of this one is going to be this method will find out how many items in the array are less than the target value and return that count. So now what I have to do here is index is 0, int total becomes 0, and then while index is 0, actually I could do this with an enhanced for loop. Do you want me to put it with an enhanced for loop instead of a while loop? Because I'm going to have to go through all of the entries in this case. With the search, I stopped whenever I found the target. But when I want to find out how many there are in the array, I have to go through the whole array. Okay, cool. So what I'm going to say, for item, which is of type T, remember it's generic, in the array, if item dot compare to target is less than 0, that means it's less than the target value, then I have to say total plus plus. And then I can return my total. So let's do, in this case, find how many less than in the array 7 and let's use printf. And then here we can say n becomes find how many are less than elk n, right? And in this case, let's see what happens when I compile this here. And it says, wait a minute, cannot find the compare to. And that's because this is a generic type. I have to say this is a type that can be compared. So I have to say extends comparable. It has to be comparable in order to do that. Once I do that, then everybody's happy. So 3 items less than 7 and 2 items less than elk. And that's true. The 3 items less than 7 are the 2, 3, and 5. And cat and dog are the 2 that are less than elk. So we're going to be using this sort of thing. There are a lot of other ways that you can use generics to limit or expand the kinds of data types that you can put in. And I'm not going to go into those. You may see them come up later in the book, and the book introduces them as needed. Yeah. So let me put a comment in here. This generic type has to also be comparable. Now, how did I know about comparable and what it does? Well, one of the ways you can find out about that is let's do a search for Oracle Java 21 API. And you'll probably want to bookmark that. Anything actually from Java 16 on above is fine also. And then I can do a search. So what's this thing called comparable? And oh, very good. There's a class. It tells me what it does. And in here, oh my God, this is an interface. Remember our interfaces that we had on Monday? Well, this is an interface. Look who implements this. Everybody in the universe just about implements comparable. And here it tells you everything there is to know about how the class is supposed to work. And it will also tell you, here's your compare to method, returns a negative integer, 0 or positive integer, as this object is less than, equal to, or greater than the specified object. And you'll notice that this is also, again, generic. So for any type T that you want to make comparable and you want to implement the comparable method, you put that in there, okay? So it's very handy to be able to look these things up. Now, I will warn you that these pages will give you more information about something than you want to know. So you'll read some of this and say, what the heck is all this? So sometimes it gets a little bit deep in the weeds, but it's a really good resource. Later on, by the way, I will also add the thing with the disks, the circles. I have implemented a compare to method for circles also, where you're just comparing the radiuses to figure out which one is bigger and which one is smaller. And once I get the whole example working, I will upload that later today. But now that we know about abstract, now that we know about interfaces, and now that we know about generics, now we can come back to this thing here, collections and wrapper classes. Yeah, and remember we have arrays, and arrays are a fixed length. You have to know the number of items in advance. You can resize an array, but it gets really ugly really fast. What we would like is an array-like container that can expand and contract as needed. Any Python people here? Okay, it's like a list in Python. And there's something called a collections. And in fact, if we go and look that up here, let me move this to the side. What's a collection? Java.util, there's abstract list, linked list, array deck, stack. A lot of these are going to be the data structures, by the way, that we're going to be using in this course. They are built into Java. However, we're not going to use the built-in ones because if you do that, you don't really learn about how they're implemented underneath, behind the covers. So we're going to be implementing them ourselves. But they're all there available for you. And it's an interface, and E is also used as a placeholder for what the element. So that's a generic element type. So the collections are made up of elements. And ArrayList is one of those collections. You'll have to import java.util.ArrayList. And then when you create an array list, you have to say, well, what kind of data is going to be in there? You have to fill in the blank for the generic data type. Should I do this in? Yeah, what the heck? I've got JShell running. And have it running now. So we'll import java.util.ArrayList. And then I'm going to say ArrayList string animals. It becomes a new ArrayList. And you'll notice it shows up as an empty list, which is fine. And now I can say animals.add ibex, animals.add of giraffe, and animals.add of, let's say, bison. Okay. And the add method returns true if it successfully was able to add something to the list. And now if I look at what's in animals, it has those 3 strings in it. So I don't have to know in advance how many items there are. This is really good if you're reading a file full of names and you don't know how big the file is. You just add it to the array list and it'll get as big as it has to get. I can also add things at a given position. So I can say animals.add at position 1. Let's put in capybara. And then if we look at animals, there it is at position 1. Just like arrays, the beginning of a list, an array list is unnumbered starting at 0. And there are other array list methods here. I can get the size, which is 4. I can say animals.get. What's at index number 3? Bison. I can set, let's say instead of 0 being ibex, let's set it to something like, oh, I don't know. What it does, it returns the old value. So you can store that in a variable for later use. That's very convenient. And now if I look at what's in animals, sure enough, I can say animals.remove 1. It returns the removed element. There I have that. Did you use array lists in the first course or not? Yeah, so this is old news. Okay. One thing that's important is that when you created that string array here, or string array list, you had to use an object. If I need, let's say, an array of doubles, or an array list of doubles, so I can say array list I'll say no, because that's not a reference type. So you cannot use a primitive type. And that is why Java provides these wrapper classes. For ints, you have a capital I integer, capital D double, capital B Boolean, capital C character, which is another style thing that y'all need to know about. Namely, by convention, an unwritten rule that everybody's expected to follow. Class, which are objects, names always begin with an uppercase letter. That's why we have capital I integer, capital E double. And variable or primitive names always begin with a lowercase letter. And please follow that rule when you're naming your variables. So if I need to get an array list of doubles, the only way I can do it successfully is to use the wrapper class. And now I've got it. And now I can say prices.add 395. Prices.add 457. And if we look at prices, sure enough, it works like a champ. There's a way to convert an array to an array list. You can read that on your own. I won't go into a big deal about that. Now, new type of collection that you did not use last semester. I don't think you did. The HashMap collection. Did you use that? Oh, they are wonderful. Hash maps solve so many problems. I really love hash maps. In Python, they're called dictionaries. In a language called Perl, which nobody uses anymore, they're called just hashes. So if you hear the word hash, hash map, hash table, it's all the same. And dictionary, they're all the same thing. And the idea is, okay, when we have an array, let's go here. So here I have an array. Let's say I have oh gracious, give me okay. Hash maps are indexed by a key that is associated with a value. And that doesn't make a lot of sense. So let's look at an example of what would be. If I have a list of cities and their populations, I can say the city New York, the name, the string is associated with a population as an integer. Okay. Do I need to draw a diagram of this or not? No, I don't. Okay. So you access values in a hash map by the key. It's as if I were able to say something like this. So I could say, for example, int population becomes city list. And it would look up New York City by the string value and get the corresponding integer and return that to me. Pretty cool, huh? Now, that's not the notation that we use in Java. Okay. Okay. The actual nuts and bolts of how we do it is very different. And let's go and grab this. Is it easier if I run it here in Genie rather than trying to do it in the browser? Okay. Yes, and today, what did I call this? Now, ordinarily, I would write these comments first instead of last, but in the book, I don't have the comments, so I have to write them last here. So show a hash map where the key is a city name and the value corresponding to the city is its population. I think it says of 2020. I don't remember when the list came up. Yeah. So I have to import the hash map class. And then my hash map, you have now inside of our generics, we have two data types, the data type of the key and the data type of the value. So we're mapping our strings to integers. And again, I could be explicit. I could put in string comma integer here. And that would be fine. But again, if you leave out the right-hand side angle brackets, if you leave them empty, Java will figure it out for you. And now I use put to put things into it. So I have New York City, and there's this population, Tokyo, and a couple of other cities. And let's compile that. And when we run it, and let's print it out and see what happens. And there it shows us the lists of keys and values. Now, there is no guarantee, by the way, that they're going to be in the same order that you enter them. I'm going to tell you that right now, and that's because hash maps are inherently unordered. A hash map just throws things into memory wherever there's room available. And if you run through a hash map and print it out, you might get them back in the same order that you entered them, but there's no absolute guarantee of it. But that's okay. So now what we could do here is we could say, I guess I'm going to have to put import java.util.scanner. And then so that's my plan. See, this is the kind of thing I'm going to write that before I start writing the code for it. Why? Because that will focus me on what I'm trying to do. So there's my objective. I'm going to ask the user for a city, then look it up in the hash map and see what the population is. And if it's not in the hash map, then I have to tell them, hey, it's not in there yet. Everybody okay with this so far? Okay. Do I want to yell? What the hell? So let's go here and let's have a string called city. And then we're going to say do the following. Print. Notice this is a print and not a print ln. Again, one of our style things. I want the prompt for the input and the input cursor to appear on the same line, not on different lines, because if they're on different lines, it's really ugly. And then what I'm going to do here is I'm going to say city becomes input dot next line dot trim. Does everybody remember what trim does? Yeah, it gets rid of white space at the beginning and end of the prompt. At the end of the input. What am I saying? Oh, by the way, I've got the scanner. You know, maybe I should create it first. There, I feel much happier now. And then what we're going to do is if that was actually, I don't have to put that comment in there because it's sort of useless. Now, if it is not the case that the city equals the empty string, then I'll look it up. And I'll do that as long as the city that you gave me is not equal to the empty string. And let's see how many errors I have. Oh, I'm surprised I got that right. And now let's just check this part to see that it works. So if I say, yeah. Okay, good. My loop is working. Again, I don't like to write an entire program and then find out later, like, okay, it's not working. I try to test this as I go along. Now, the next question is, okay, how do I get the population out of there? And let's go back here and take a quick look. Well, actually, I could go here and say hash map. Yeah. And here they use K for key and V for value for their generic variables. Get, perfect. Returns the value to which the key, specific key is mapped, or null if this map contains no mapping for the key. So I had put and get. Get is exactly what I want. Okie doke. And it returns a V-type value, which is a good thing. So now what I'm going to do here is I'm going to say integer population becomes cityinfo.get city. I give it the key, which is a city, the string, and it's going to give me back an integer. If the population is not equal to null, and notice I have to have a capital I integer, because if I try and put a null into int, bad things are going to happen. I'm not sure what the bad things are, but I'm not even going to try. I'll try it later just for an experiment to see how it works. Population is not equal to null. Then I'll printf population of is %d. And that'll be the city name and the population. Otherwise, there we go. So now if I say Tokyo, great. If I say, ooh, that's interesting. Missing for argument format specifier %s. Yeah, I keep doing that. I have a placeholder here. Guess what? Did I put in anything to fill in that placeholder? No, I did not. And this is one thing, when you get an error message like this, do not freak out. Just say, okay, well, let's look at then what it says. I have a missing format argument. So I have a format specifier %s, but there was no argument for it, which means I never provided something to fill in that placeholder. And it turns out that this was in HashMap example.java in line 36, which is indeed exactly where the problem started. Okay, this should work a lot better. First of all, let's just try something called, see if that trim does what it's supposed to do. Cool. So there's your hash map. And there's all sorts of places where these just come in so ultra handy. Whenever I have something, I want a lookup table. I have some key and I need to find the corresponding value. And there's no law that says it always has to be a string and an integer. I could do it the opposite way. For example, I could have integers and look up strings if I wanted to show the words that represent a certain number. Or I could have doubles to strings or strings to doubles. I can add any type of object to any other kind of object that I want. So hash maps are really wonderful. We're going to be talking about them later on in the course also, and we're going to show how to implement hash maps ourselves. And then there's the set collection, and that's a mathematical version of a set, and an unordered set of elements where no item appears more than once. So it's an interface. When you need an actual set, you'll use a hash set. I do not have any examples of this. I've got about 5 more minutes. Do you want me to try and do a real quick example of a set? Okay, we're not going to be using them a lot, but let's see how well I can program here. Actually, let's see how much I can screw this up in 5 minutes. Let's save this as hash set example.java. Okay, so create a set using a hash set as its basis. Add some stuff to it and print it out just to see that it works. And so we're going to have to import java.util.hashSet. And we're going to have to change this name to hashSet example. Yep. I don't really need my scanner on this one, but okay. Now the question is, how do I create a hash set? Oh, wow, am I glad I have this? I can look it up. Hash set. And it says here, and it implements set and it implements collection. Cool. Okay, so I know that I'm safe on that. Doop-de-doop-de-doop. You can give it a hash set, empty one, default initial capacity of 16 elements, and a load factor. Don't worry about load factor. We'll talk about that later. So all I need to do is create a new hash set out of a type. Okay, well, that makes me happy. So let's do a hash set of string called name set is new hash set. Now the question is, how do I put things into it and how take things out? And let's go and look at the methods here. Add. And it says adds the specified element to the set if it is not already present. If the set already contains the element, it leaves the set unchanged and it returns false. Ooh, so that way we can tell if something's already in there or not. How convenient is that? And then return will give you a true or false if the set contained it. Or equivalently if the set changes as a result of the call. All right, so what we can do here is, let's do name set.add of actually what we want to do here is it returns a Boolean, right? And then what we have to do here is let's do a result is name set.add of Maria again. File that and run it. There we have it. And by the way, notice that they aren't in any particular order. I don't think those are in the same order as I entered them. Okay, so with sets and hash maps, there's no guarantee. Well, there's your no guarantee right there. And because it was already in the set, and then I can say result equals name set dot remove of let's see what happens if I do that. And it's true because it was removed. And if I try and do it again, what happens? This time it's false because it was never in there to begin with. So there's sets. Again, we're not going to be using them a lot, but if you need to, now you know how to do it. Okay. And again, there's a lot of more stuff you can do. You can get the size. You can change it to an array of objects. How nice. You can iterate over them, so you can use an enhanced for loop to go through that. You can ask if it contains a certain object or not. And when I look at this document, it's just like this kid who writes a thank you message to his aunt. It says, "Dear Aunt Martha, thank you for sending me the book about elephants. It told me more about elephants than I wanted to know." Okay, well, Look at this stuff. It will tell you more than you ever wanted to know about any one of these classes in Java. So it's break time here. So at 10:15 restarts lab. Take a break if you'd like. If you want to, then I suggest that we continue working on the abstract and the interface stuff, the assignments. There is no assignment for generics, but you need to know about them. It's important to understand what they are. Okay, meanwhile, what I'm going to do during lab time and during the break is I'm going to figure out why the hell that circle thing isn't working the way I thought it would. I have a thought. Okay. You want me to just keep the projector on while I play around with it or not? Okay, I'm going to stop recording here. Yes.